metallic conductance is due to the movement of electrons. So it also depends upon the number of electrons which is present. The conductance of electricity by ions present in the solution is called as electrolytic or ionic conductance. Passing direct current changes the composition of the solution. Okay, so we can't pass direct current through the solution. It will change the composition of the solution. This is one problem. Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry, Vidyashram School of Excellence, Mysore. So today we are back with session 5 of the chapter Electrochemistry. So in the last session, we discussed and studied about the products of electrolysis, right? The different factors on which the products of electrolysis depends, and we in detail also studied about the electrolysis and the products of electrolysis under fused sodium chloride as well as H2SO4 we discussed in the last session. So in today's session we are going to study about the next important part of the chapter, that is conductance and conductivity of the electrolyte solution. So before reaching to the conductivity part, we need to be knowing certain other terms as well which will lead to this conductivity, and thereby we have to study in detail about conductivity, molar conductivity, equivalent conductivity, all of that. Okay, so now beginning with the conductors. Okay, so first we are going to begin with what is conductors. So conductors are substances which allow the passage of electricity through it, right? You will be already familiar with it. So substances which allow passage of electricity through them are known as conductors. Conductors conduct electricity, right? They conduct electricity or allow the passage of electricity through it. So now they are classified into various groups. Okay, so now let's see how the conductors are being classified into. So the first one is metallic conductors. Metallic conductors. So electrical conductance through metals are called as metallic conductance. So the substance which is conducting the electricity is a metal, then we call it as metallic conductance, right? So electrical conductance through metals are called as metallic conductance. Now what is the reason of this metallic conductance? Why metals are able to conduct electricity? It is due to the movement of electrons inside the metals. Due to the movement of electrons, yes, due to the movement of electrons, the metals are able to conduct electricity. Now it depends upon the nature and structure of the material. So it depends on which metal we have chosen, right? It depends upon the nature of that. It also depends upon the number of valence electrons per atom. That means, as I just said now, the metallic conductance is due to the movement of electrons. So it also depends upon the number of electrons which is present. And the last one, it also depends on temperature. Right, so this is metallic conductors. Now the next one is electrolytic conductor. Now what is electrolytic conductor? The conductance of electricity by ions present in the solution is called as electrolytic or ionic conductance. So in an electrolytic solution, when it undergoes dissociation, what does it form? It forms ions, right? So due to the presence of ions, it can conduct electricity. Okay, so the conductance of electricity by ions, it is due to the presence of ions in the electrolytic solution, right? So this ability is rendered by ions that are present in the solution due to the dissociation of the electrolyte. So if we have taken an electrolyte, due to the dissociation of electrolyte, we get the ions. Okay, and due to this is the conductance of the solution, right, which is called as the electrolytic conductance. For example, we are taking sodium chloride. So under the solution, okay, it dissociates into Na plus and Cl minus ions. Na plus and Cl minus ions. Now these ions are responsible for the conductance of the solution, and it is not the sodium chloride. So what you have to remember in it is that in the solid state, it cannot conduct electricity. The electrolytic conductance is only for the ions. That means in the solution phase. Either it is in the aqueous or molten phase, then only it can conduct electricity, and not in the solid state. So it is because of the ions that the conductance is produced, right? It depends upon the nature of the electrolyte. Okay, the nature of the electrolytic solution we have taken. The size of ions and their solvation. The size of ions and their solvation, how easily they are getting dissolved in the solution. Now, the nature of solvent and their viscosity, also it depends upon the nature of the solvent, and concentration of the electrolyte and also temperature. So, these are the factors in which electrolytic conductance depends. Right. Now, moving on to the next one, that is insulators and semiconductors. So, what are insulators? Insulators are those substances which do not conduct electricity, right? So, the substances which do not allow the passage of electricity through them are called as insulators, and they have very low conductivity. And what are semiconductors? They have conductivity in between that of conductors and insulators. So, conductors we studied in the beginning. Conductors we studied metallic conductors and electrolytic conductors, right? Then we studied about insulators and semiconductors, which is having properties in between that of conductors and insulators, right? So, I hope you are clear with conductors, insulators and semiconductors, right? So, moving on to the next one, that is conductance of electrolytic solution. So, before studying about conductance and conductivity, you need to be knowing certain other factors and other terms as well for understanding conductance and conductivity. So, the first term is resistance. Now, what is resistance? The word itself is an opposition, right? Resisting something. So, what does resistance mean? The tendency of a material to stop the flow of current is known as resistance. So, it is opposing the flow of the current. So, it is the tendency of a material to stop the flow of current, which is known as the resistance, right? So, the resistance of an object, now let's see how we can represent it in a equation format. So, resistance of an object is directly proportional to the length and inversely proportional to the area of cross section. So, whichever material we have taken, the resistance, which is represented by capital R, will be directly proportional to the length of the material we have chosen and inversely proportional to the area of cross section, right? So, that is what is shown here. R is directly proportional to L by A. So, to remove the proportionality, we introduce a constant. So, that is R is equal to rho L by A. R is equal to, now the proportionality sign is gone, R is equal to rho L by A. And this rho you can see here, this rho is called as the resistivity, right? It is called as resistivity, right? Then how can you define resistivity then? R is equal to rho L by A. Yes, this is what we studied now. How can you define resistivity? Can I say resistivity will be equal to resistance? R will be equal to rho when my L is 1 and A is 1. The value of L and value of A is 1. Then what happens? This gets cancelled. 1 by 1 is 1, right? So, R will be equal to rho. Right. So, how can you define resistivity? Resistivity is equal to the resistance when it is 1 meter long and the area of cross section is 1 meter square. Right. So, when the length is 1 meter and area is 1 meter square. Right. So, when the value of this both is unity, we can say that resistivity will be equal to the resistance, and we can also rearrange it and write in terms of resistivity as rho is equal to RA by L. Right. So, that means if I am taking this rho here, this is L by A in here. So, if I am taking it into the other side, it becomes A by L. Right. So, rho is equal to RA by L. So, this is the equation for resistivity which is shown here. And the unit is ohm meter. You already know the unit for resistance is ohm. And from where did you get meter? For area, it is meter square, and for length, it is meter. So, meter square by meter will give you meter, right? And for resistance, it is ohm. So, what will be the unit? Ohm meter. So, I hope you are clear with resistance and resistivity. So, now moving on to conductance and conductivity. So, the inverse of resistance is called as conductance. Okay. So, resistance means it is resistance means it is resisting the flow of current, right? So, what will be conductance then? It is the ability to conduct electricity. So, resistance will be inverse of conductance, right? So, it is represented by the symbol G. Conductance is equal to inverse of resistance, that is 1 by R. We already studied the equation for R. R is equal to rho L by A. Okay, so then what will be G? G is equal to 1 by R. So we have to take the inverse of this equation. So G becomes 1 by rho into A by L, which is shown here, A by rho L. Okay, and the unit of conductance is Siemens. Okay, so this is conductance. Then moving on to the next one, that is conductivity. So conductivity will be the inverse of resistivity. Okay, so the inverse of resistivity is called as conductivity. So this rho stands for resistivity, right? So 1 by rho will be the conductivity. So how can I write? G is equal to K into A by L. So what is this K? K is called as kappa, which is the conductivity. Okay, so conductivity is represented by the symbol K, which stands for kappa. Okay, so how can I write it in the terms of conductivity then? If I want to write it in terms of K, K will be equal to G into, I keep it here, and this A by L will go to the other side of the equation. So it becomes L by A. So this is the final equation for conductivity, which is K is equal to G into L by A. And this part you can see L by A. This L by A, which is the length by area of cross section, is called as the cell constant. L by A is called as cell constant. Okay, for different materials, the cell constant will be always a constant, right? For different materials, the length and area of cross section will be a constant, right? Hence, L by A is called as cell constant, which is represented by G star. Okay, right. And how can you define conductivity then? Conductivity will be equal to conductance. Right, conductivity will be equal to conductance when the length is 1 meter and area of cross section is 1 meter square. Right, and the unit will be Simon meter inverse, or else you can also represent it in Simon centimeter inverse. Okay, so I hope resistance, resistivity, conductance and conductivity is clear for you. Right, now moving on to the details of conductivity. The measurement of conductivity of ionic solutions. So the conductivity, what we are discussing here is about electrolytic solutions, right? It is not about metallic conductors. We are studying in this chapter about electrolytic cell, right? So that means electrolytic conductors we are going to talk about. So how can you measure the conductivity of an electrolytic solution? If it is a solid, we can measure the conductivity. If it is in a solution form, how do we measure the conductivity of any substance, of any electrolytic solution? So, there are few problems. For measuring resistance of ionic solutions, there are two problems. The first one is passing direct current changes the composition of the solution. Okay, so we can't pass direct current through the solution. It will change the composition of the solutions. This is one problem. So how can you connect it in a circuit and measure the conductivity, right? A solution cannot be connected to the bridge like metallic wire or a solid conductor. If it is a wire or a solid conductor, we can measure it by connecting it using a circuit. But if it is a solution, it is an electrolytic solution, then how can we connect it? Right. So, usually to measure the resistance, we use Wheatstone bridge. Right. We use Wheatstone bridge, which is written here, the Wheatstone bridge. So, if we have to measure the resistance using Wheatstone bridge, it has to be a solid or a wire. So, then how to measure the conductivity of the electrolyte solutions? So, we use conductivity cell. So for that we use conductivity cell. So this conductivity cell, as you can see here, it looks like this, inside which the electrolyte will be present. Okay, so the electrolyte can't be, as it is in the solution form, you can't connect it with the circuit. So what do? You take the conductivity cell inside which the electrolyte solution will be present. Hence you can calculate the resistance for it also. Right. So this conductivity cell consists of two platinum electrodes which is surrounded by platinum black. So it consists of two platinum electrodes which is connected by a wire. Okay. So it consists of two platinum electrodes coated with platinum black. So the resistance of the cell is given by this equation which we just studied now. R is equal to rho into L by A. Okay. Rho is the resistivity, L is the length and A is the area of the conductivity cell, area of cross section of the conductivity cell. So from that, R is equal to rho L by A. Instead of rho, I can write 1 by K also, right? Resistivity is the inverse of conductivity, right? So it becomes 1 by K into L by A. Okay, so now what is this part? L by A, it is called as a cell constant, right? So R is equal to G star by K. So from this conductivity cell, when we can calculate the length as well as area of cross section, if I divide it L by A, I'll get the cell constant, which is G star. Right, I'll get the cell constant, as well as from this I'll get the cell constant. Now if I am able to calculate the resistance as well, I can calculate my conductivity. So this is the aim. Okay, we have to find out the conductivity of the electrolytic solution. So for that, what we use, a conductivity cell inside which the electrolytic solution will be present. Okay, so for that, what we have to calculate first, the cell constant will be calculated first of the conductivity cell. So different conductivity cell will be having different cell constant, and for a particular conductivity cell, the cell constant will be having a constant value. So once the cell constant is found out for the conductivity cell, it is used for measuring the resistance or conductivity of any solution. From that, we can calculate the resistance or conductivity of the solution. So how do we calculate this? Yes, using Wheatstone bridge. As you can see here, this is the Wheatstone bridge. So you can see R2 here. Yes, so this R2 is the conductivity cell which is having the electrolytic solution present inside this. So as you can see, this is the conductivity cell now. So now this is in a solid. Okay, it's inside the conductivity cell. So I am able to connect it with the circuit. Yes, so that problem is solved. Now R1 is a variable resistance. You can change the value, and then you have R4 and R3. Okay, so this is the Wheatstone bridge. Okay, so it consists of two resistance R3 and R4, a variable resistance R1, and the conductivity cell having the unknown resistance R2. Okay, so R2 is the conductivity cell, R1 is the variable resistance, R3 and R4 are the other resistance. Okay, so now using the conductivity cell, I can connect it with the Wheatstone bridge. Okay, so from that, the Wheatstone bridge is fed by an oscillator O. There will be an oscillator, and then from this, the unknown resistance can be calculated. So from the Wheatstone bridge, you are already familiar with the equation. R2 by R1 will be equal to R4 by R3. So from that, if you rearrange it, what is it that you have to find out? R2. It is the unknown resistance. We want to calculate the resistance of the conductivity cell, right? So R2 will be equal to R4 R1 by R3. Right, R4 R1 by R3, which is this equation. Okay, so from this we calculated the resistance of the conductivity cell. So now what happens? We already calculated the cell constant. Now we know the resistance as well. We can calculate the conductivity. Okay, so now using this equation, R is equal to G star by K. Once we calculate the cell constant as well as the resistance, we can calculate the conductivity. Okay, so this way we can calculate the resistance as well as conductivity of the electrolytic solution, which is done using a conductivity cell. So I hope this is clear for you. Yes, what is resistance, what is resistivity, what is conductance, what is conductivity, and how to measure the conductivity using a conductivity cell also. Okay, so using this equation, R2 is equal to R1 R4 by R3, we can calculate the resistance of the conductivity cell, thereby the conductivity also. Okay, so I hope it is understood. So I hope conductance and conductivity and how to measure the conductivity is clear for you. So in the next session, we'll go into details of conductivity. The next one is molar conductivity, and then there is an important law also we have to study, that is called as Cauchy-Rash's law. So these two we will discuss in the next session. So I hope what and all we have discussed in this session is clear for you. So that's all for today. Thank you.